I can use addition and subtraction within 100 to solve word problems. Yes, that's right. We're going to use deal.
Hello, second graders. I'm glad you're here today. Hey, wait a minute.
There, that's better. Let's get ready to do some math. Everybody's favorite books are back. Bedtime Math, a fun excuse to stay up late, by Laura Overdeck, illustrated by Jim Paulette. Again, these have amazing deal problems to use. Remember that when we're using deal, the D is for drawing, and there's two basic kinds of drawings we're looking for. Either a number bond, also called a math mountain, or compare bars, also called tape diagrams. For problems where something is coming into the scene, we're getting something more, we'll use an add to drawing, which is going to be the number bond. For take from problems, it's just the opposite. Something is leaving the scene, something's going away or being subtracted. Again, we're going to use a number bond. For a put-together take-apart problem, nothing's coming or going. You have some giraffes and some hippos. How many animals do you have all together? Things like that. Again, a number bond. For the comparison problem, we're comparing two kinds of items or two groups and which has more or fewer or who has more or fewer. Those we're going to use the tape diagram or comparison bar drawing for the D part of deal. Stretching the truth. Okay, first of all, do not try this at home. Do not try this without training. And here we go. Even if you aren't afraid of heights, walking on a really high bridge can give you a scare. If that isn't enough of a thrill, you can take a long elastic cord called a bungee. Hook one end to the bridge, hook the other end to yourself, and jump. You then fall at a frightening speed until the bungee stretches enough to pull on you, at which point you get yanked back up at full speed toward the sky. Then you slow down, stop in midair, and fall again. Let's just say, if you're going to measure your own bungee cord for this, you'd better do the math right. Here we're going to do the big kids question. If you're bungee jumping off a 100-foot high bridge and your bungee starts at 37 feet long, how many more feet can it stretch without letting you smack into the ground? You might have noticed the words, how many more feet can it stretch without letting you smack to the ground? So as we did compare problems last week, you might have noticed those key words. This time, I thought it would be fun to do a 3-digit number subtracting a 2-digit number. So we can see that 100 is the larger part, 37 is the smaller part, so it goes in the smaller section of the compare. And our unknown right now is how many feet we can stretch without hitting the ground. Now that we're done with our math drawing, that helps us see what information we need to find and create an equation. So 100 feet minus 37 feet equals blank feet. Now that we've done our drawing and equation parts of deal, we're ready to move on to the answer. To solve, we can set up our problem vertically, 100 minus 37 with a line underneath. Remember that when we're lining up vertically, our ones should be all together. 0 ones in 100 should be above the 7 ones in 37. The middle 0 in 100 represents or means 0 extra 10s in 100. That should be directly above the 3 10s in 37. There are no 100s in 37, so nothing should be in the hundreds place. I noticed when grading our last test that some students were doing lots of different things with the ungrouping, where the middle digit in the tens place of a 3-digit number, when ungrouping 100, they started putting random numbers there. So I wanted to make sure you understand where those numbers are coming from once again. So we did our hundreds, tens, and ones chart. That's what the HTO stands for. This is just a quick way to draw it out and understand our thinking. So the one large square represents 100. We have these fancy blocks at school that are base 10 blocks, and so we all decided that the big square would represent 100 in our drawings. So we have our 100 block. We're not going to draw the 37 because that's how much we're trying to take away. And that's how long our chord already is. We want to know what's left in the length of 100 feet above the ground before we smash into it. So if we look at the 100, we realize that to take away 7 ones from 0 ones, I can't do that. To take away 3 tens from 0 tens, I can't do that. But I don't have 0 ones and 0 tens. Really, I have 100. So if I ungroup the 100 into 10 tens, then I have some tens to take away 3 of them. But I still don't have enough ones. So you can see here how I've ungrouped by crossing off the blue lines through each of the numbers. I no longer have 100. I have 0 hundreds. I have 10 tens. But then I ungrouped by slashing through that 10. Now I have 9 tens so that I could put 10 ones into the ones place. This is where in class we often use the strategy of drawing a magnifying glass to look closer and make sure that we had enough 100s, 10s, and 1s to subtract what we needed. Here we can see that now we have 9 10s. Yes, we can take away 3 10s. 10 1s. Can we take away 7 of those? Sure we can. At the same time, we can see in our drawing that the 100 block was ungrouped into 10 10 sticks. Then one of those 10s, the orange arrow, was ungrouped into 10 ones dots. So we have 100 block, no longer there. 10s sticks, now there's 9 of them, and 10 ones dots. Then we can have 6 10s to take away and 7 ones to take away. Also remember that 9 10s and 10 ones, 9 10s is 90 plus 10, still have that 100 there, just written in a different way. Here we can see how whichever way we choose to solve, it should be the same results. Here you can see in my picture how I've used subtraction signs, a straight line, through the ones that I'm actually subtracting, so as not to confuse my ungrouping. So I can't use any of the parts that I've already ungrouped. So I subtract 3 10s and 7 1s. Now we can see that I'm left with 6 10s, 3 1s, or 63. Whoa, rewind. Remember the problem? We're doing math and we need to make sure that this makes sense. Do we really want to hit the ground and use that full 100 feet? Let's reread the problem. Notice the part where it says, how far can it stretch without letting you smack the ground? So let's back it up to 99 feet or less. But if we had done that to begin with, we wouldn't have got to do all that ungrouping practice. In reality, how far can my cord stretch? My bungee cord can stretch 62 feet or less. I hope you had fun with that one. Let's do another. Speaking of stretching, everybody stand up, get the blood flowing again, put your arms up over your head. Putting your arms up over your head can help relieve anxiety, and stretch. Oh, that feels good. Now we can focus some more. Ready? This one's called pressure cooker. If you've ever been to a diner where you could see the cooks cooking, you know what a crazy job that is. Short order cooks cook food that will be served in a short amount of time, hence the name. And it's usually a mad scramble. They're cooking burgers, hot dogs, eggs, and pancakes all at once, all requiring different timing and all in a rush. As the cook runs the griddle, the toaster, the milkshake machine, it's a miracle that any food comes out cooked right at all. Okay, here's the big kids question. If pancakes take 8 minutes to cook and burgers take 5 minutes, which will take you longer? 3 rounds of pancakes in a row or 5 rounds of burgers? So think, what kind of problem type is this? Some of you might be thinking, well, 5 rounds of burgers, that's a put together take apart problem. So is 3 rounds of pancakes, and you'd be right. If you also were thinking, well, it's a compare problem because we're comparing which one's going to take longer, then ding ding, you've got to the essence of the problem. Usually, we're trying to find the difference in the amount, but here we're really wondering which will take longer. So we don't know where to put pancakes and burgers in our compare problem yet. For our equation, we might actually have a greater than sign. Which one is greater than the other? We don't know that yet, so we have to break this problem up into separate parts. So first, we're going to have to figure out how many total minutes for the pancakes. Each batch takes 8 minutes. So batch 1, batch 2, batch 3, all of my parts of my number bond are labeled. So we'll also need a number bond for the total minutes of burgers. 5 rounds at 5 minutes each. So let's add these up. 8 plus 8 plus 8 equals 24 minutes. 5 groups of 5 is 25 minutes. So which one takes longer? You got it. The 5 rounds of burgers is going to take bonus 1 minute longer. So my complete sentence, 5 rounds of burgers takes longer than 3 batches of pancakes. Then I can go back and fill in my compare bars as well as my equation. 25 is greater than 24. So the burgers take longer than the pancakes. All right, sticking with food, we're on to cheese next. Say cheese. In England, many towns hold a strange event called cheese rolling. People crowd together at the top of a wide grassy hill while someone throws a big round wheel of cheese down the slope. Once the cheese rolls a few feet, the race begins, and with a roar, everyone starts chasing the cheese. The cheese bounces and rolls really fast, so the people have to fling themselves on the ground and roll like logs to keep up. Lots of bruises, lots of broken bones, but the first person who reaches the cheese gets to keep it, which is way more exciting than just buying one at the store. All right, big kids question. If 50 people start chasing the cheese, but 13 get so bruised and banged up they never reach it to the bottom of the hill, how many people make it to the end? All right, think about what problem type we have here. 50 people start, 13 people get so bruised they don't get to finish. Yep, It's a take from problem. Some of those people aren't gonna end up at the bottom. Okay, I've already set up my deal. My drawing is a number bond to go with my take from problem, an equation, a vertical form set to answer my problem, and a complete sentence to label it. So also my drawing is labeled and everywhere else that's needed. So as I solve that, 50, take away the 13, and what am I left with? That's the unknown part. In my vertical form equation, I have 50 minus 13. And so I need to get some ones from the tens place to be able to subtract the 3 ones. I can't subtract them from 0. So once I ungroup one of the 5 tens to make 4 tens, then I can put 1 10 over in the ones place. So 4 tens, 10 ones is just renaming 50 another way. Then I'm ready to do the actual subtraction. 4 tens minus 1 10 is 3 tens. 10 ones minus 3 is 7. So 50 minus 13 is 37. 37 people make it to the end. I can label all of my other parts of deal with my missing addend from the equation. If you need to pause and stretch, refocus yourself for the end stretch here. Whether or not, April might be done, but this still applies. The great thing about being a meteorologist or weather forecaster is that no one ever notices whether you're doing your job right. The map goes up, the weather guy or gal tells us what temperature it's going to be tomorrow and whether it's going to rain or shine, and then that's it. We never see what they said yesterday and whether that actually happened. Any job where no one checks how well you're doing must be the best job in the world. But if someone starts tracking the numbers, these people are going to be in trouble, especially in Michigan. Big kids. If the weatherman predicts that it will rain half the days in April, but only a third of the days are rainy, how many days were called wrong? Remember, April has 30 days. Okay, so we've got some fractions here, but what problem type is this? We're comparing those fractions, aren't we? So let's get ready with some compare bars. In my compare bars, I thought of half of 30, the amount of days in April, and that would be 15. Well, if I broke 30 days into 3 parts, that would only be 10 days. So 15 is the bigger part. So 15 days are the half of April. A third is the smaller part. That's less than a half. So 15 days minus 10 days, 5 of the days in April were called wrong. This one's for all you Lego lovers like my son Trevin. Getting a Lego up. Get it? When you open a new set of Lego building bricks, it's fun to follow the instructions and build that car, castle, or jet plane before you lose any pieces. Some sets get really complicated. You have to add lots of tiny pieces in just the right places or angles won't line up and propellers won't spin. Just think, as hard as it can be to build it, someone else first had to plan the whole thing. What object the set should make, what colors it should be, what funky pieces it should use. That person is called a Lego designer. But even with all those decisions, being a Lego designer isn't all work and no play. Get set, big kids. If you're designing a castle that uses 200 pieces and a quarter of them have to be pink, how many pink pieces do you have to throw in there? All right, so what problem type is this? We're not getting rid of anything, nothing's coming into the scene. It's a put together, take apart problem. We know for a put together take apart problem, we need a number bond. So at the top, I have 200 Lego pieces labeled. But wait, how many parts are there? It said a quarter of them need to be pink. So we have to think about what that means to have a quarter. We've heard that with hours. A quarter of an hour means 15 minutes because that's one of 4 pieces in the hour. And we've heard it with money. There are 4 quarters in a dollar. So quarter means that it's one of 4 pieces. So now that we've established that 1/4 means one of 4 pieces, or a fourth, then we have 4 parts or add-ins to our number bond that equal up to that total of 200 pieces. I've labeled the 1/4 pink because that's what our question was asking, so it's important to label that pink. The other colors don't matter. I thought about solving this in a couple of different ways. So we know that 200 can easily be broken up into 100 and 100. 2 of the quarters would be 100, and the other 2 quarters would be the other 100. Then I can think about what each quarter represents out of how much of that 100. So maybe you can think of that and get your answer. Another way to solve would be to count by tens into each quarter. So I counted my pink ones with a pink line and the others with a black line. So count with me as we get up to 200 total pieces. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200 total pieces. Now you can see that there are 5 lines in each of the quarters. They have an equal amount. That is very important, that each part is equal. So we have 10, 20, 30, 40, 50 if we count all 5 tens in each quarter. So 50 plus 50 plus 50 plus 50 equals 200. So my pink part and each of the other quarters are each worth 50 pieces. Okay, I can make sure to finish off my deal by labeling all parts and having my complete sentence. I need 50 pink Legos. All right, get ready for your last one. As you can see, I was having so much fun with these deal problems, I couldn't decide, so I included all the best ones I could find. This one's called Getting Fired. Another one of those, don't try this at home, and one of those things you hope never happens to you, whatever the meaning is. Okay, here we go. A cannon is big. Let me start that again. A cannon is a big, heavy metal object with a hollow tube that shoots big objects, usually cannonballs, at the circus and other events, though sometimes they light the cannon and a person comes flying out over everyone's head. It's a real living person, and this is a real job you could do. Don't do it. Luckily, they don't fire the cannon by making something explode inside it. Usually, there's a giant spring or a jet of air that pushes the person out. But that's little comfort when you're about to sail through the air at over 100 miles an hour. Big kids! The world record for a human cannonball is 193 feet. If you build a cannon that shoots you twice as far, how far will you fly? Okay, so let's think through problem type. Yes, we're adding 2. So an add 2 problem for the first time. I made this one a 3-digit, but Remember, for second grade mastery, we just need you mastering the 2-digit plus 2-digit addition. 3-digit is extra, but I'm just demonstrating it here one more time. Add 2 problems also have a number bond. So here we don't know the total for the twice the world record, but we know that the world record is 193 feet. So I've labeled the feet FT period for the abbreviation for feet. And then I've just put it in both of the addends since we're doubling it. Twice means doubled. So my equation is 193 plus 193 equals blank. I can show that in vertical form, 193 plus 193, the 100s over each other, the 90s in the 10s places directly above each other, and the 3s in the 1s places directly above each other, all lined up. So we can start with the 1s place, and we know that 3 plus 3 is 6. There's no need to regroup anything from the 1s place. Then we can see in that I did a hundreds, tens, and ones drawing also. So now we can see that 5 tens and 5 tens makes 10 tens, which is equal to 100. And that's all the regrouping we needed to do. So I can now see that there are 3 hundreds, 8 tens left over because the 10 tens we took out of there and made 100 with them, and 6 ones. And the squiggle is just where I moved my 6 down so that it would all be in one line, easy to read, 386. You can see that in my vertical form, the 9 and 9 made 18 tens. The 10 tens are represented as a 100 with that tiny 1 under the other 2 100s right on the line that kind of represents equals in a vertical problem, so that I can't forget that that 100 is there. I also could have done it with new totals below. So 3 plus 3 ones equals 6. 9 tens plus 9 tens is really 180. And then the 2 100s is 200. So then I just add all 3 of those totals to get my final 386. So it's the same answer, just a different strategy, a different way to get it. So I've got my drawing, my equation, my answer solved a few different ways. One way is plenty. I've just given some options. And so finally, I need to label it and give a complete sentence. If I build a human cannon that shot twice as far as the world record, it would shoot 386 feet. So we've done a lot of different deals, and now this video has included all of the different problem types. And so you are set to continue doing deal, and it's your turn. You get to do it all on your own. Woohoo! You made it through the video, and let's finish the year strong too. I know this seemed like a long video after being out of school for a while, but it's less than 30 minutes, and I put some breaks in there for you if needed. So go enjoy some math and finish strong for the rest of the school year. Go second graders!